Hello, fellow PSC 103 students. I am Devin Xiong, and I was tasked with doing a specific type of igneous extrusive rock, and I chose to do the specific type of rock on Obsidian, right? So let us start with talking about, or before we jump into uh, Obsidian, let us do a brief explanation of what an igneous extrusive rock is. So, an igneous extrusive rock is a rock that comes from magma, right? It comes up from the volcano, and instead of like an intrusive rock where it cools under the Earth's crust, this type of rock will cools on the Earth's surface. And because it cools on the Earth's surface, it will cool down really quickly due to air or water. And so, since it's cooling off really quickly, it doesn't have time to create as strong of bonds, and so you really won't see any crystals like what is shown in these rocks right here. Uh, some of these, igneous extrusive rocks you see will have holes like this, which will give it that sponge-like look to it. And most of the time, you'll see these rocks, and you'll notice that most of them are smooth or grainy. And yeah, that is the brief explanation of what an igneous extrusive rock is. So let us talk about the rock I chose, which is obsidian. So yeah, so one, of course, it's an igneous extrusive rock. But what's different compared to the other types, or what's different compared to what's different of obsidian compared to other types of igneous rocks, extrusive rocks, is that obsidian is called or is classed as volcanic glass, where it has no crystal structure to it due to how it is formed, right? And it's mineral compensation. It has a jet black color to it. It fractures instead of cleaves due to its bonds being really, or it not having any bonds. It fractures in a conchoidal way. So if you look here, you'll see it kind of resembles a shell, and that's where it gets the name conchoidal. And of course, if you look at it, you can tell that it has a smooth and glass texture to it. So let's talk about how it is formed, shall we? After a little spin, it is formed from magma that is high in silica or silicon dioxide, SiO2, or SiO2. It has low water content, which helps it cool down really quickly and form that glass look to it. And it's also the reason why it has no crystal structure to it. It's because it cools down so fast that the atoms inside cannot create bonds with other atoms. Therefore, that's why it doesn't have a structure to it. And also, since it's cooling in like a damp environment, basically water or cool air, it doesn't have the time as well because it cools down in like 5 seconds to a minute. And sorry about this photo. There's really no photos of. It's very hard to find a photo of an actual like. I've seen the magma that's hot and silicon actually cool down and become obsidian. It's too quick and it's a very hard thing to take a photo of or even film. So let's talk about where it can be found. You could find it anywhere in the west part of North America. Some examples would be Utah, California, and Oregon, and like Baja California or something like that. You could also find it in South America, Japan, Italy, Iceland. But there are definitely more places that you could find it at, as shown in this picture below. Um, these these 5 areas, or technically 7, is where you, or is the most like common areas of where you would find obsidian. But usually you'll find it anywhere around an active or dormant volcano, as it needs magma for it to actually for obsidian to form. And let's jump to its uses and its applications, right? And so obsidian is used in medical uses like a tip of a scalpel, because some patients can be allergic to the metals that are used in the of the tip of the scalpel. So obsidian is used as it's a very sharp stone, and so it can be used as a replacement. Of course, we have like art and decoration. For example, an obsidian vase, right? And lastly, it can be used for weapons, as shown in this Aztec weapon. And we use this, or obsidian is also used for historical significance, as it is used to like identify how old, or maybe like an idea of how old they were, how old a civilization was, or how techni- uh, how advanced they were for their time. So, all in all, let's talk about like the takeaways and conclusion of obsidian, shall we? One, it comes from lava that is high in silicon dioxide or silica. It cools rapidly. It doesn't have a crystal structure. It is what is called volcanic glass. You will find it around active or dormant volcanoes and has little to none water composition. Thank you for listening.